So this is called quadratic equation because this term is x to the second. And if you want to graph it, it's a square. And each side, the size of that is the length and width are exactly x. So the area of that is x squared. And the reason we call it quadratic, because this square has four sides. That's what the quad comes in, right? Quad means four. So when you say something like x squared equal 9, first of all, that's equation because the equal sign, and also this term, x squared. So that's why we call it quadratic equation. Good?
Okay. Yeah, sorry.
Okay, so we did this, and now today we're actually going we're going to derive something called formula. Formula basically have symbols like say y is equals to 3x. That makes a formula, right? Every time when you find the value of x, you times 3, you got y. So formula always have symbols to it. And now we're going to find the formula for solving problems like x squared equals to 9, x squared equal to 7, or x squared equals to 4. Now, before we have to do it, each one on its own. But what's powerful in algebra is that we can have a general solution. We can say, okay, this kind of problem, we can generalize that as x squared equal to c. And c is just a number. Good?
Okay.
Okay. And what we see is something like this. We can rewrite as x squared minus c equal to 0, right?
Okay.
And now we're going to rewrite this because this is x squared minus square root of c squared, right?
Okay.
And this, we know this is x plus square root of c times x minus square root of c. Then we got this equation. And this is called factorization. We basically break this quadratic equation as the product of two linear equations or two linear expressions. Good?
Okay.
And well, if this is true, which means x, either this is true, and which give us the solution that x is negative square root c, or x minus square root c is true. So that gives us x equals square root c. Good?
Okay.
And because there's a negative and positive, and we write this as a shorthand, it's x equals to plus minus square root c. Good?
Okay.
So because that now we have a formula, our formula is if x squared is equal to c, then x is equal to plus minus square root c. So therefore, when we have something say x equal to 9, then x is plus positive negative square root 9. We know square root 9 is 3, so it's positive 3. Good?
Okay.
We just basically plug in the value to c. Or can x squared is 25, then x is plus minus 25, square root 25, which is plus minus 5. Good?
Okay.
Okay, so to derive this, what we did here, there's two things we need to know. Two properties we're using. One is something like this. Trying to rewrite it, is x plus a times x minus a that will give us s squared minus a squared. Good.
Okay.
Do you remember this?
I think so. Yes.
So this is one of the important identities in algebra. So the other way around is x squared minus a squared is x plus a and x minus a. Okay, and there's some applications in mental math. That means you do that in your head. Is when you see something like this, say 19 squared minus 11 squared. Now we can either just find the square root of 19, then find square root of 11, then we minus that. So that which means we can do 19 squared. We can do 360 minus 121. 360 minus 121, that is 0. That's 4. That's 2. So it's 240. We can do that. Or we can use this identity. This is 19 plus 11 and 19 minus 11. And we know this one is 30. 19 plus 11, 30. And this side is 8. So therefore, we got 240. Good?
Okay.
Yeah, so this is actually a well-known trick in mental math, is to use this identity. I'll give you a couple more examples. For example, say 25 squared minus 5 squared. So we can do that as 25 plus 5 and 25 minus 5. One is 25 plus 5, 30. And 25 minus 5 is 20. So that gives us 600. Good.
Okay.
And so do you see that? That makes the mental math a lot easier if we do this trick, right?
Yep. Does.
Okay. Now I'm give you an example. 77 squared minus 67 squared, and see how you do that using this trick.
That'll be 144 plus 10. That would be
So
multiply that 144 times 10.
yeah, times 10.
Okay.
So that's just 1,440, right?
Yes.
Because time 10, that's easy. We just add 0 to it. I'll give you another example. 67 squared minus 53 squared.
Okay. $1,680.
1,680, right?
Yeah.
So that basically is 67 plus 53, then 67 minus 53, and this side is 120, right?
It's
5, 6, 120, right? Times this side is that, right?
Yep.
So 12 times 14, 8, 4, 2, 1, so 1,680. Good.
Okay.
Yeah, so this is actually very famous identity is x plus a times x minus a equals to 0. Not equals, sorry, equals x squared minus a squared. And sometimes we write as this, you see different forms, but it means the same thing. It's a squared minus b squared. Okay.
Okay.
And we also have something like this, x plus a squared, that is x squared plus 2ax plus a squared. Okay.
Okay.
And x minus a squared is x squared minus 2ax and plus a squared. Okay.
Okay.
Yeah. So those are things that those three in identities is very important in algebra, and that's something actually we need to remember, because that becomes quite useful if we know this. And so how do we prove that? How do we prove that it's true? So we got x plus a and x minus a. So do you remember the technique called FOIL?
Do not. No.
Huh?
I said I do not. No.
Okay, so basically the way we do it is x times x. Now this is the first term in this hypothesis within that hypothesis, not hypothesis, parenthesis, and also this also the first term. So that's where the f come from. That means f is first, O means outer, I means inner, L means last. Good.
Okay.
So x times x, x squared, then x times a, those are considered outer because those are kind of in the outside on this. And that is x times a is negative ax. And then a times x, those are considered inner term, plus ax. Then a times a, negative a is negative a squared. And that considered as last. Good?
Okay.
So basically what we did is the first term multiply, and then we do this outer times this outer term. And then we do inner, that, and then we do the last is this and that. Good?
Okay. Yeah.
Yeah, so in this case, then what we have, negative ax plus x, that cancel, right? That so it's become x squared minus a squared. Good?
Okay.
So now we can prove that that's the case. Now we know x plus a, x minus a is equal to a squared, no, not a squared, x squared minus a squared. And then we have this a x plus a squared, which is x plus a and x plus a. So same technique, x times x, x squared, that's the first. Then x times a, those are the outer terms, ax then a times x, that's the inner term. And then a times a, the last term. So this and this are the same. So we can write it as x squared plus 2ax plus a squared. Good?
Okay.
So when we learn algebra, basically is to learn how to prove something is true. So x squared plus 2ax plus a squared. Of course, we also have x minus a squared. Now, there's two ways to prove it. One way is just notice that this is the same as x plus negative a squared. And now we can just use the identity we had before is x plus 2 negative a x plus negative a squared. And that gave us x minus 2ax plus a squared. So that's one way to do it, just to use whatever this one we already proven. Another way to do it is just do the FOIL. And that is that is x minus a times x minus a. Then we do the same to the FOIL. X times x, x squared, then x times negative a, ax. Then that times that is minus ax. Then that times that is a squared. And then we can combine this term, which is x squared minus 2ax plus a squared. Okay.
Okay. That seems like one of the easier ones, FOIL technique.
Yeah, right. Yeah, that's what we use when we just do something like that, when you have two terms on each side. And sometimes it could get a little bit more complicated, but that's what we have right now. Okay. Let's actually work on the FOIL a little bit. So let's say x plus 3 times x plus 2. If we use FOIL, x times x squared. X times 2 is 2x. Then 3 times x, 3x. And 3 times 2 is 6. So x squared, 2x plus 3x, 5x. And that's that. Good? Are we okay here? Hello? Hi. Are we good?
Yep. You didn't hear me?
Yeah, I think there's a glitch there. Okay.
Okay.
X plus 4 times x times 3. So I just let you to work on this, okay?
Okay.
See what you got.
All right. We have x squared plus no first. Okay, so x squared plus 3x.
So x times x squared, yeah. And x times 3 give us 3x. And then?
Okay, so then 4x
Yep, very good.
plus. Okay, so would I add 4 plus 3 or would I just
4 times 3, yeah.
4 times 3? Okay.
So that'd be 12, right?
What's 12? Yeah.
And then we just combine this term. It's called like terms. And that give us 4x plus 12. Good.
Okay.
Okay, let's do a couple more, okay? X plus 2, then x plus 5.
So x squared plus 5x
Mm-hmm.
plus 2x
Mm-hmm.
plus 10.
10, yeah.
Okay.
The x squared plus
Squared plus 2x or 5x,
5x plus 2x.
7x.
Right,
Okay.
plus 10. Very good. Let me give another one. X plus 3 times x minus 2.
Okay. So the x squared. Okay. X squared plus negative 2x
Yeah,
plus 3x.
right.
That would be plus 1.
3 times 2.
Oh, so it's not negative 2 times 3.
Yeah,
Okay. So plus 6.
minus 6 because
Oh.
3 times negative 2. Good.
Oh, okay.
Yeah. Okay, so now x squared, the negative, positive, that's x, right?
Yep.
And
Okay.
got 6. Very good. Let's go x minus 4 and x minus 3. See what you have.
So x minus. Okay, so x squared
Mm-hmm.
minus negative 3x
Mm-hmm.
minus 4x
Mm-hmm.
minus.
Well, negative, negative, positive. So it's add.
Okay, and then you add plus 3. So plus 4 times 3 is 12.
Right. And then we combine the like terms. So x squared minus 7x plus 12. Good.
Okay.
Yeah. So that's called, this is something called FOIL. So make sure you keep the operator. Okay.
Okay.
Let's do one more. X minus 3 and x minus 7.
The x squared minus negative 7x.
So minus 7x. Yep.
Oh, okay.
And then that,
It's minus 3x
right. And negative times negative.
positive, right?
Yep.
Okay, so not very good with my multiplication table.
Okay. 3 times 7.
Yep, 3 times 7, that is 21.
21. Very good. Then we combine the like terms.
Okay.
7 and 3x.
9x.
7, 3.
You said you add them, right?
Yep.
Okay. Oh, 10. Whoops.
Yeah. Minus 10x plus 21. Very good.
Okay.
Yep. So that's what we have for today. Okay.
Okay.
All right. I'll see you next time.
All right. It's a good class. Bye.
Yeah. Bye.